So, do you hear the word physics and immediately feel your heartbeat start to race? I mean, does your blood pressure literally drop the second you open that textbook? Well, welcome to this explainer. Today, we're tackling something that haunts students everywhere, especially those of you facing the massive, high-stakes hurdle of the Thanwaya Amma exams. You know, physics definitely has a reputation. It's so often seen as this completely insurmountable wall, an absolute monster just waiting to ruin your GPA and, well, your dreams. But listen, we are going to change that narrative completely, right here, right now.
So is physics really the boogeyman of high school? Does it kind of feel like a series of incomprehensible spells and ancient curses that you just can't decode no matter how hard you try? Look, it is completely valid to feel that way. Seriously, so many students do. But here is the best kept secret. It's not magic, and it is definitely not a monster. It really just requires a specific set of tools. And today, I am so thrilled to pivot away from all that fear and hand you the ultimate solution. We're going to slay this monster together.
Okay, let's dive into this. Here is your complete Monster Slayer toolkit. We have 5 definitive steps that'll transform your anxiety into total confidence. Imagine the quantities, physical sense in units, the language of symbols, graphical relationships, and finally, math as your secret weapon. Let's kick things off with step number 1. Imagine the quantities. Don't just leave words on paper.
You know, the absolute biggest mistake you can make in physics is just staring at abstract text and trying to rote memorize it without actually visualizing what's happening. Remember, physics is the study of the physical universe. It's literally all around you. It isn't just dry ink on a textbook page. On one hand, you've got these highly academic terms like electric current and resistance. Kind of sounds boring, right? It's hard to grasp. But on the other hand, look at this brilliant analogy of cars and bumps. Instead of trying to memorize invisible electrons flowing through a piece of copper, imagine the electric current is just a line of cars driving down a busy road. The road is your wire, the cars are your current. Now, what happens when those cars hit speed bumps? They slow down. It gets a whole lot harder for them to move forward. Those speed bumps, that is your electrical resistance. The more bumps you have on the road, the harder the movement becomes. By visualizing cars and bumps, you've just perfectly understood Ohm's law and resistance without breaking a sweat. You didn't leave the words on the page, you brought them to life.
Moving right along to step 2, physical, sense, and units. It's time to activate your sixth sense. To be a successful physics student, you have to develop a logical, deeply physical intuition for the numbers you're calculating. They aren't just random digits floating out in space. They represent real-world scale and magnitude. Let me give you a perfect example of what happens when you don't use this sixth sense. Imagine you're grinding through a massive multi-step exam problem to calculate the radius of the Earth. You crunch the numbers, you do all the complex algebra, and bam, your calculator spits out an answer. 100 kilometers. Now stop and really think about that. 100 kilometers. That is the distance of a quick road trip between 2 neighboring cities. The Earth is a massive, life-sustaining planet that literally takes days to fly around. Does it make any logical sense whatsoever that its radius is only 100 kilometers? No, absolutely not. Yet so many students will just blindly write that number down and box it in as their final answer, simply because the screen on their calculator said so. Which brings us perfectly to this incredibly common, honestly kind of hilarious mindset. Awesome, the teacher won't notice. But this really exposes the ultimate flaw in studying physics just to pass a test by guessing. You literally cannot bluff your way through the fundamental laws of the universe. Your teacher will definitely notice, and more importantly, those strict graders for the Thanwaya Amma exams, yeah, they will absolutely notice. You've got to logically estimate numbers and units. If your answer for the speed of a bicycle comes out to be, I don't know, the speed of light, your physical sense should immediately scream at you, hey, I definitely messed up a decimal point somewhere. Trust your logic, not just your calculator's display. All right, step 3, the language of symbols. Let's decrypt the code. Think about it this way. If you were suddenly dropped into a foreign country, you'd really struggle to survive if you didn't know the language, right? Well, physics has its own entirely unique language, and you need the decoder ring to understand your teacher, actually read the textbook, and successfully set up the problems. These symbols are your keys. We have symbols like R, V, and the formula P equals M over V, and their meanings, resistance, voltage, and density. You absolutely must memorize these symbols. Why? Because when a high-pressure exam problem says a circuit has a 12V power source, you literally do not have time to sit there and wonder what the letter V stands for. You need to instantly know its voltage. These symbols are the keys that unlock the vital data within any physics problem. Once you can read the code fluidly, the whole problem practically sets itself up for you to solve. Step 4, graphical relationships. Are we talking direct or inverse?
Physics isn't just about single, isolated numbers. It's all about how things change in relation to one another. It's the study of relationships in motion. Let's move to this and see exactly how this builds. Step 1 is displacement. Step 2 is time. Step 3 is velocity, which is simply the rate of change. When you plot displacement against time on a graph, you aren't just drawing a random line on grid paper. You are basically watching physics happen right before your eyes. The slope of that line mathematically and physically reveals the velocity. A steeper line, that means a faster velocity. A flat line, that means zero velocity. The object is literally standing still. You need to be able to look at a graph and instantly know if two variables have a direct relationship, where one goes up and the other goes up too, or an inverse relationship, where one goes up and the other goes down. The graph tells the true story of the physics.
And now we arrive at our fifth and final step. Math is your secret weapon. The inseparable siblings? I literally cannot stress this enough, and honestly, this is where so many students get stuck. Physics and mathematics are siblings that never, ever leave each other's side. If physics is a shiny new sports car, math is the heavy-duty engine under the hood, actually making it run. You simply cannot separate them. To be an absolute boss at Newton's laws of motion, you can't just know the theory. You need to master vectors. You have to know exactly how to resolve pushing and pulling forces into X and Y components. And look at magnetic induction. To truly grasp how magnetic induction works in the real world, you must be thoroughly grounded in calculus and derivatives, specifically understanding the rate of change. If your underlying math skills are weak, I hate to say it, but your physics will always be weak. But if you sharpen that math sword, you will cut through complex physics problems like butter. Math is the heavy lifting tool that makes the physics concepts actually work on paper. So let's quickly recap this ultimate toolkit for slaying the boogeyman. 1. Visualize the abstract. Turn dry concepts into real-world things, like cars and speed bumps. 2. Develop a logical number sense. Don't ever let your calculator lie to you. 3. Memorize the symbol code so you speak the language fluently. 4. Master graphical relationships so you can immediately see how the world moves. And 5. Sharpen your math skills, because math is the essential engine of physics. See? Physics isn't impossible, my friends. It just requires training your brain correctly, understanding the material deeply, and refusing to just memorize blindly. When you apply these 5 steps, the monster completely disappears. So the crucial point is, you really don't have to do this all alone. If you want to absolutely guarantee your success in Thanwea Ama and slay this physics monster for good, you need an expert guide in your corner. Reach out to Mr. Mustafa Matar immediately at the number you see here. Having an experienced mentor who teaches you exactly how to think rather than just what to blindly write down is an absolute game changer for acing this incredibly demanding subject. If this explainer opened your eyes and gave you some much-needed relief today, please don't forget to like, follow, and subscribe to the Dose of Knowledge channel for more brilliant breakdowns just like this one. And hey, tag a friend in the comments who absolutely hates physics and desperately needs to see this toolkit. I want to leave you with this final provocative thought. Now that you actually hold the weapons and you know the strategy, are you ready to stop running, stand your ground, and finally slay the physics monster?